Hello everyone, and let's do some LeetCode competitions together. That's a first for me. I'm gonna narrate as I am participating in this weekly contest, 215th, on the infamous website LeetCode.com. Alright, so let's start. The first problem. These are our algorithmical problems, by the way, very typical for a programming interview question. Alright. Design an ordered stream. There are n pairs and tuples id and value, where id is an integer between 1 and n and value is a string. No two pairs have the same id. Design a stream that takes the n pairs in an arbitrary order and returns the values over several calls in increasing order of their IDs. Implement the order stream class. Ordered stream is a constructor that accepts n values and sets the current pointer to 1. And then this method here, insert, stores the new ID value pair in the stream. After storing the pair, if the stream has stored a pair with ID equals to pointer, then find the longest contiguous incrementing sequence of ID starting with ID equals to pointer, and return a list of values associated with those IDs in order. Then update pointer to the last ID plus 1, otherwise return an empty list. Okay, since I was reading, I got absolutely nothing. Let's read it now silently. Oh, I see. Okay, so we're inserting those pairs in a random fashion, not in order, but then we are required to return them in increasing order as long as there are IDs there. Okay. Fair enough. Okay, so I think, and there are only up to 1000 elements. I think an array would be a suitable representation for this, and then every time we want to return values, we will just do exactly as in the example here, increment over all the valid members of this array until we reach a gap or the end of the array, and then return that sublist. Okay, so let's have this, let's call it elements array. Let's initialize it in the constructor. Elements ID equals to value. Oh, never mind, that's of type string. And then we'll return a array list implementation. That probably with latest Java is not needed. Okay. While ID, and we can reuse the same variable, I could have created a new variable to increment here. While ID is less than, let's keep that. I could just take elements length, but I could also just keep this. I think it's a bit more elegant and readable. So until we reach the end of the array, well, we're within the array and the current element is different than no. Okay, I'm now trying to understand better this example. Obviously, I would think that we would return C. So I'm trying to understand when are we returning the empty list a bit better. Oh, okay, I missed this completely. Sets the current pointer to 1. Okay, if the stream has stored a bare idiot pointer, then find the longest. That makes sense. Okay, so I guess in that case we'll be only returning values when we hit the pointer. Okay, that's relatively easy then. If pointer -1 while pointer less than n or pointer let's actually zero index this pointer, and we'll have to do some magic here to make sure that this is actually comparing correctly. Alright, so we'll go through the list pointer by pointer and increment pointer here. Yeah, what I'm doing is the moment there is an ID that equals the current pointer, it will always start with the first element, obviously, like in this example. We'll go through the array with the pointer, and as long as there are elements, we will be adding them to the response and return them. As soon as we hit a gap, our pointer will stop there, and we'll wait until it receives a new query equal to the pointer. And we got an out of bounds error on line 13. ID -1. I could at this point do this. 0 ID. This is a 0 based ID. Okay, my answer is no, empty AA, BBCC, empty DDD, AAA. Let's try. And that works fine. Okay. Yeah, so what we did is, back to our example, before the query with 1 we're just recording numbers in the array. Once we hit an insert query with an ID equal to our pointer, which is the first element here, then we keep going through the array until we hit a gap or we reach the end of the array, and we accumulate everything we go through in the response for the given query, and we return it. Next we continue just filling in values until we again reach an element with an ID equal to the pointer, and we do exactly the same. Okay, that's that with the first problem. Let's check the second problem. For 4 points, medium difficulty level, you could say, or easy to medium, I guess. Maybe medium. Determine if two strings are closed. Two strings are considered closed, let's see the definition, if you can attain from one from the other using the following operations. Operation 1, swap any two existing characters. For example, in the A, B, C, D, E, if you swap B and D, that would be a close one. And then there is a second operation you can do, transform every occurrence of one existing character into another existing character, and do the same with the other character. For example, AAC ABB becomes BB CBAA. All A's turn into B's and all B's turn into A's. You can use the operations in either string as many times as necessary. Given two strings, word 1 and word 2, return true if word 1 and word 2 are close, and false otherwise. Okay, so in this example, ABC and BCA are close because we could swap BC here, it becomes ACB, and then in ACB we can swap again B and A, and it becomes BCA. And in this case it's impossible. Obviously if they are of different length it would be impossible because we have only swap and transform operations which could never change the length of our strings. So just as a thought here, not to forget it, if one of the lengths is different than the other length, return false. This could never be true. Okay, so let's see in that scenario, 10 to the 5th. That means I need n log n solution at first, or like n square root of n or something. I don't want to go for a quadratic solution with this upper bound because it will be too slow. Okay, is this a dynamic programming candidate? Can there be a greedy solution? Swap any two existing characters. Okay, if I can swap anything, then I could sort the arrays with swaps, right? Let's see. Yeah, okay, if my array was something like this, I could swap first with second, and then this, and it would be ordered. Okay, so let's say I have two arrays that are sorted. What could I do with sorted arrays to prove that I can turn from one to the other? Obviously, if they're sorted, if they're equal elements, not necessarily. Okay, so the next operation besides the swaps is replacements. I could replace every occurrence of one existing character into another existing character. What does that mean? That means if there are here 3 A's and here there are 2 A's, and I could switch them to different characters. So in this scenario, I would have to convert the B's to A's. Oh yes, it's just switching. Okay, so if I have A, B, B, I could swap those, have it B, 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 A. So I guess I could swap them and I could put them to any place. This now gets reduced to the question, are the counts, the different counts of elements matching between the two strings? In other words, if in the first string I have some character that's 3 times, another that's 2 times, and here I have 1 time, 2 times, 1 time. Example, A, B, B, C. That wouldn't work, right? They need to be the same occurrences. All right. Guys, that's my son. He's fun. Okay, so I'll count every letter in every word. I'll get the frequency of every letter. Because I can swap anything, like ordering doesn't really matter. I can do any ordering. So what matters to me is the counts, and I want to make sure that with all the swaps I can make correct count. So I'll check the A's, for example, and if I could swap anything from one string to the other, I would. And let's print to see if we got correctly. Those. Cannot find. Oh yeah, that's gotta be a method because this is the string class, and I guess I'll do that. I didn't need actually the sorting, and so therefore I didn't need this. ABC, BCA. Okay, that looks correct. Let's hide you for a second and run a test case. Alright, that looks good. So I'm getting the frequencies now. I need first to have the same elements, right? So in this example, because I have z's here, this is never going to work. I can never get rid of an element. So first thing is I want to make sure that there is no case in which one element is 0 in one of the arrays and more than 0 in the other. That would be definitely not working. And then second, I want to make sure that I have the same numbers, because then by circular swaps I could make them, I believe, work as expected. Let's see if that's true. I mean, that kind of feels true. If this was a real interview question, I would think about it a bit more. But because it's not, I will just run it on a gut feeling and see how it goes. Okay, so first is if counts 1 is equal to 0 and counts 2I is more than 0, return false. Same is true the other way around. In other words, we cannot produce new numbers. Okay, next we're gonna sort the counts 1 array and sort the counts 2 array. And if we get equal numbers, including the zeros for those that are missing, then we're good. We have equal count, so we could make this work. If counts different than counts 2I, return false, otherwise return true. And different length case can stay, just for simplicity. I don't know if we need it. I definitely don't need the sorting here. A, C, B, let's try this. True. Let's try A, A, A. Let's just check if this would give me a false. It gives me false, that's good. I'm just debating whether I need a special case. Probably not, for different lengths, and it will just make the solution shorter, although a bit less efficient. Okay, and let's check with this. True. Let's check AABBSS. False. Okay. And that works. What I really did was, here I'm checking element if any character is in one string but not the other, we cannot make strings match. And if we have different counts, we cannot make them match either. As long as they're matching counts, although of different characters in the strings, with enough applications of operation 2, we can make the same letters have the same counts in the two strings. And then we don't care about their position in the strings because we can do a random number of swaps. So we can treat the strings as ordered arrays of characters. Okay, I'll just do one more thing here to simplify even further. I believe that's good. Instead of sorting, we could have done here a hash map count, but this is only 26 symbols, so sort doesn't cost us much. Let's move to the next problem. And we have 54 minutes left. Minimum operations to reduce x to 0. You're given an integer array nums and an integer x. In one operation, you can either remove the leftmost or the rightmost element from the array nums and subtract its value from x. Note that this modifies the array for future operations. Return the minimum number of operations to reduce x to exactly 0 if it's possible. Otherwise, return -1. -1. Okay, so in this example, we have the array 1, 1, 4, 2, 3, and we have x equal to 5. The optimal solution would be to remove the last two elements, 2 and 3, and reduce x to 0. And in this example, we can't do it. If you notice in the constraints, all the numbers are positive. The first and the last are already too big, and so by the first subtraction we already go to -1 or to -5, depending on left or right part of the array we start. So we return -1, it's not possible. And in this example, the optimal solution is to remove the last three elements and the first two elements. 5 operations in total. We have 10 to the 5th number of elements and 10 to the 4th. That means 10,000, and 10 to the 5th is 100,000. X is 10 to the 9th. That's what, a billion? One way would be to go greedily with always the bigger number, as long as it works. Now the problem with that is, can the solution actually not include the big number? And yes, the answer is yes. If this here was 4 and 4, and this here was 2 and 3, in this case here, I obviously shouldn't start from the number 4. I should start from the smaller number. On every iteration, though, there are only 2 possibilities. Okay, so if you think about this, if you think this problem in this following way, you need to reach to some index from this side and to some index from that side. And then you need to shift those indices left or right. So it's like a moving window problem. And you want to find the smallest window. Like if you're wrapping around here, imagine this array wraps around and then you have the same elements again. you really are looking for this window that must include either 4 or 2 and can spread in both ways, to the right and to the left. And yeah, you look for the smallest window, and that window size should not be obviously more than the array size. So let's say we have this twice. I will keep incrementing here until I reach the total array or more than x. Once I reach x here, then I can start removing and adding on the other side to see if I can stay equal to x. Every time I go to more than x, I'll be removing from the right. Okay, let's see if that window logic works. Let's double this array. I don't need to really explicitly do that. I don't need the extra memory. I could just work with the original array. But I don't know. It makes it a bit easier to visualize, I guess. Missed the new operator, runtime error. Oh yeah, because of this weird thing I did. Okay. Yeah, maybe I don't need that. Let's see. This would be my sum. Maybe I'll skip this whole thing here and just work on the original array. So starting from the beginning, I keep adding until I reach the end, or I get more than x. Let's call this sum, although in some languages that would be a problem using the method name sum as a variable name, but in Java that's fine. If the sum exceeds x or is equal to x, you break. Further down, there's no point to continue. If sum is equal to x exactly, best size I'll think later about the corner cases of when exactly to break. So if the sum is equal to x, then best size equals to size, because this is actually a valid answer. Now we have reached whatever spot. Let's say our answer is 7 and we have reached here to 8, and now I have to subtract on this side and add on the other. While this is end index, which will be n minus 1. Just now I want to mark where I am up to. Let's do this. Size minus 1, start index, and the end index is at n minus 1. While start more than or equal to 0 and more than or equal to 0 if if they overlap, I can only decrement. I cannot have more elements. So in other words, if start plus n minus end minus 1 is more than n, then I have to decrease start and sum minus num start. As I'm writing this, I feel the variable names are so bad here. The naming of start and end doesn't make much sense. What I'm saying here is I have this from the beginning of the array, and this end index here is what I'm calling start. While, let's say I am here at the very end at 4, this is what I'm calling end. This is where actually the end part of the array starts, and this is where the beginning part of the array ends. And so I realized these names are not ideal. And here we have one element that is not included in this example. Okay, if size more than n, decrement. Else if sum more than or equal to, I guess here we can do it like this, or sum more than or equal to s, decrement, else increment. So sum plus add from the end and decrement that end. This also reduces the size, and this increases the size. That's readable. We'll get the best size. And let's just have a normal example here. We'll remove this variable. Line 29, out of bounds, -1. Start is -1. Yeah. Size 3. Then let's check what's the sum. Sum 6. This is correct up to here. Then we are reducing on this side. If sum equals x, there you go. And nothing got fixed. A bit more of debugging. Okay, removing 1. Not that this has anything to do with it, but 0, 1, 2, 3, 4, that's correct. Oh, I got it. Yeah, just my messages are wrong, but my actions are correct. So removing element 2. I'm still a bit confused of what do I remove. Size gotta be size -1. Okay. Okay. Max value. Let's see, your answer is 2. That's correct. That should give me -1. And it does not. Oh, hold on. Yeah, that's correct. Five. Alright, so what did I do here? Verbalizing my thoughts. I filled my array from the start. Let's say in this case, I'm looking for the number 10. Continue filling it up until I reach a sum that's more than or equal to 10. So here the sum is 3, 5, 25. I stop here. Now, I could start adding from the end, but in order to do that, I need to start removing from the start. So before I add anything more, I need to remove first this 20. I'm going back, I'm subtracting here to 3 and 2, and then I'm looking at my result. Am I still above or equal to x? If so, I continue removing. If not, then I start adding on the back. And if I am less than x, I'll add from the back. I'll keep adding until I again become too big, in which case I'll continue removing from the front and so on. This, I think, should work fine. Let's check some corner cases. That should give me 3. Huh, and it does not. If start equals to 0, if start is more than or equal to 0, and one of those two is true, there was a subtle bug. I would stop when I reached the beginning of this, and so the case in which I have only elements from the back wouldn't work properly. Let's do one more example. Okay. Okay, minimum 1 element. Let's try 1. This. Good. Alright. Let's submit and see what happens here. And I exploded. Let's see why. Let's return the print statements. Oh, okay. I guess I am incorrectly doing this here. Let's see what's my sizing. Size 2, size 3. If size is more than or equal to n, I should be removing. Okay. Check all the other examples. Make sure we haven't broken any of our existing code, any of our existing logic. Five is correct. Obviously, if you take parts from the back and from the front that overlap, you can get a bigger number than the total. In other words, if I get here 1, 2, 3, 4 as a suffix of this array and 1, 1, 3 as a prefix, and I add them together, I'll get a total that's bigger than the total of all my numbers. My prefix and my suffix can never overlap, and that's what this check here is for. Okay. Let's try one more time. And this time it worked. Alright, I have only 18 minutes for the hardest problem. Unlikely to solve it on time, but that doesn't mean I shouldn't try. Maximize grid happiness. You're going for the integers, and introverts count and extroverts count. Oh, a psychological problem. You have an m by n grid, and there are two types of people, introverts and extroverts. There are introverts count introverts and extroverts count extroverts. You should decide how many people you want to live in the grid and assign each of them one grid cell. Note that you do not have to have all the people living in the grid. The happiness of each person is calculated as follows. Introverts start with 120 happiness. Look at those happy guys. And lose 30 happiness for each neighbor, introvert or extrovert. Extroverts start with 40 happiness and gain 20 happiness for each neighbor, introvert or extrovert. Neighbors live in the directly adjacent cells north, east, south, and west of a person's cell. The grid happiness is the sum of each person's happiness. Return the maximum possible grid happiness. Great. Alright. The maximum happiness of an extrovert is their inherent 20 happiness plus 20 for each neighbor. And so that adds up to 120, which is, if you notice, the happiness of an introvert to start with. That problem is one proof that extroverts or introverts can achieve the same amount of happiness in life. Great philosophical point. Hold on. N by n. The grid is only 5 by 5. So what would be a brute force solution? I would put all possible 5 by 5, by the way, is 25. Worst case scenario, I guess, is exactly half of them being introverts, or 12. 12 or 13, doesn't matter. So I need to place 12 people in 25 boxes in all possible ways. And then the other 6 or so people in the remaining 13 boxes. Will that time out? 25 multiplied by 24 multiplied by 23 and so on. 25 factorial over 12 factorial or whatever, 11 factorial. That would time out. Quite the number. If I have both an extrovert and an introvert, do I benefit from putting them both? For sure I do. First of all, obviously, putting just extroverts on the board makes sense. But putting an extrovert when they are introverts also makes sense. Let's take a look. If I have a person here, and a person here, and a person, and I smack an extrovert in the middle, that extrovert will gain from all its neighbors, but the neighbors would lose from him 20 points. So it will be at net zero. Okay, so I'm not losing anything. And there's one more thing. If the grid is sparsely populated, I'll be better off putting introverts. If people are adjacent to each other, then extroverts will work better. What I'm doing right now is trying to find some pattern. I don't think I'll find it in the next 9 minutes. But yeah, I'm trying to find some logic that would allow me to greedily put certain people on the board. I guess you could try a different, so this could be a combination. It doesn't have to be completely greedy, but maybe there are some smart ways you can position people. It's 7 points problem. So it's not the hardest of them all. It's not an 8 points, which is the maximum difficulty problem. One way would be to, in a checkers manner, put all my introverts and then start filling the gaps with extroverts, I guess. And then the moment this gets too dense, I can reevaluate and replace the introverts I've put. Alright, and the contest ended. I'll do it as a homework. If you notice, 61 people solved this. Let's see what's my position. Oh, I guess 119 people solved it. But if you notice, there are people that solved the first 3 problems way faster than me. Alright, that concludes it, guys. I hope you enjoyed this competitive programming session. That's a great preparation technique for coding interviews at any major company. And just out of curiosity, let's take a look at this problem here and see if in fact it was given at any companies. And you'll see this actually has been asked at Salesforce in the last 1 to 2 years. And the minimum operations reduced to 0 was asked by Google. Here we passed the Google question. And Postmates asked to determine if 2 strings are close problem. And this easiest of them all has been asked by Bloomberg. As you see, they are identified as an easy, the first one we've solved, and 2 mediums. And we failed the hard problem, so we'll lick our wounds, come back to it, and attack it with fresh strength. Maybe it's an apple. Cheers, guys, and thanks for being with me during that experience. See ya!